Okay, hi everybody. So you still have your packet of foldables for this unit. So please take out the 5-4 one. It's on equilateral and isosceles triangles. So that is your title for today, equilateral and isosceles triangles. So before we begin, let's talk about what is an isosceles triangle. Sorry, the pictures are really bad here. I apologize. So in an isosceles triangle, we have a base, and then the two sides that are equal are legs. And the definition of an isosceles triangle is a triangle that has at least two legs are congruent. Okay, now you usually see an isosceles triangle like this, but you know they're going to fool you and draw it this way, right? So it could be rotated, but it's isosceles because there's at least two sides that are congruent. All right, so let's go over some of these theorems. The first one is the base angles theorem. And what it says is if two sides of a triangle are congruent, then the angles opposite them are congruent. All right, so copy that down first. I'm going to draw this again because it's really blurry. So this is what your picture looks like. Okay, so if two sides of a triangle are congruent, then the sides opposite them, the angles opposite them are congruent. So if you look at AB, right, the angle opposite would be C. And if you look at AC, the angle opposite would be B. So according to this base angles theorem, we could say angle B is congruent to angle C. Okay? Now, theorem 5-7, now we have the converse of the base angles theorem. So notice in the picture, okay, now they're telling us that we have angle B is congruent to angle C. What do you think it's going to say, right? If the base angles are congruent, it's going to tell us AB is equal to AC. So, if two angles of a triangle are congruent, then the sides opposite them are congruent. So in the picture, since we know angle B is congruent to angle C, we can now say side AB is congruent to side AC. At any point, if you guys need to pause this video so you can just make sure you have everything written down, feel free to. And you can watch it more than once if you need to. Okay, let's try this example. So we're using this diagram. It says if HG equals HK, right? So it's saying if these sides are equal, what do we know about the angle? So like if I was to draw that separate, HGK, if I know they're equal, then we know angle G would be congruent to angle HKG. And then it says, number 2, if KHJ, assuming this is J, I'm going to use a different pen. So if this angle is equal to KJH, this angle, right? So let's say we draw it separate. So these two angles, right? So this is the converse of the base angles theorem. Then the sides opposite are equal. So HK would equal KJ. That's J. Okay. So yes, you're going to see triangles that are connected. You're not going to see basic triangles like that. All right, let's move on to the corollaries. So remember, corollaries are just an extension to the theorems. So the first corollary, 5.2, is corollary to the base angles theorem. And what it says is if a triangle is equilateral, so that means if all sides are equal, then it is equiangular. So if all three sides are equal, then all three angles are equal. That's what equiangular means. All angles are equal. And then corollary 5.3, corollary to the converse of the base angles theorem, pretty much is the opposite. If a triangle is equiangular, then it is equilateral. So if we know all angles are equal, then we can say all sides are equal. All right, so let's see if we can find x and y here. So if you don't notice, they're telling you that this angle, and this angle are equal, and this angle are equal. Okay, so since these all are 60 degrees, it's equiangular, which means all three of these sides are 4. So y is 4. And then if you look at this triangle, right, we have base angles are equal. So if the base angles are equal, this is equal to this. So if this is also 4, this equals 4. So if x plus 1 equals 4, then x must be 3. Right? And if you need to see it, I'm going to draw it this way. So if this is 4 and this is x plus 1, we know these must be equal. Alright. For those of you who want to challenge yourself, feel free to pause this and try this problem without me. Now it does say to explain how to prove it. If you want, sometimes it's easier to just prove it. So again, pause this if you want to try. Alright, so we know PT is congruent to ST. And we also know PQ is congruent to SR. And we're trying to prove PQT, so this triangle, is congruent to SRT. So if you didn't notice, right, the entire triangle is isosceles. So you could say angle P is congruent to angle S. By the way, I should probably mark that. Those are equal, those are equal. So if P equals S, think about what theorem we can use. Right? It's either the base angles theorem or the converse of the base angles theorem. Good, it's the base angles theorem. Right? Because we know the sides are equal, therefore the base angles are equal. Then, if you mark up your diagram, right, and you only focus on the triangles, it's SAS. And we are finished. So awesome job if you got that without me. So again, if you guys need to pause this, or there you go, you can pause it there and copy down the notes that you missed. So please glue this in your notebook on the next page. Again, equilateral and isosceles triangles are a great title. And here is your classwork. Whatever's not finished is due tomorrow. Also check all of your answers in the back of the book. So help each other out. Hopefully Mrs. Pelliconi is walking around helping you guys. If not, I will answer any questions tomorrow. All right, bye guys.